Alright, so here's our current problem. We can't really continue with the assembly here so much without, I mean, there's a couple things we could do, but what I'm really concerned about is this lead screw bracket. This is the bracket that goes at the end of the lead screw, and this part right here attaches to the bed of the lathe, and the end of the lead screw goes through here, and this basically acts as a bearing on the end there, and also to support. Now, on later models, they beefed this up. They actually made this out of a more solid part. This is made out of that Zamak material, which is basically it's an alloy consisting of aluminum and zinc and I think maybe magnesium and some other goodies or whatever. You can look it up if you haven't already seen any of my other videos talking about Zamak. Zamak was used because all of these parts could be cast cheaply. So on a less expensive home hobbyist type of lathe like this was designed to be, this was a popular alternative to more expensive machined pieces. So I talked about what I could do to fix this. I could try and epoxy it. It's one option. Try and braze it. Welding's pretty much out of the question. From what I've read online, the heat of welding just destroys it. Brazing can be pretty tricky too. I could replace it if I wanted the original one. There's the part number right there, 9-16. They do occasionally pop up on eBay, and I will keep my eyes open for one. The last one that popped up on eBay was $40 and change, which is I mean, not outrageous, but it's more than I wanted to spend. I didn't want to put too much money into that. So the other option I talked about was maybe making one of these. I mean, this is something that, boy, I'll tell you, if I had a Bridgeport, I could make a honey of one of these, you know, without too much difficulty, I don't think. But I don't have a Bridgeport or any other kind of milling machine. So now what I'm thinking is, I'm tempted to try and solder this. And this could meet with complete disaster, but the reality is it's unusable to me the way it is anyways. So I'm gonna take a stab at soldering this sucker and see what the heck happens. I'm just thinking if I build up and if I build up in this area right here on both sides, I might be able to make a fairly decently strong structural repair. Considering this was by design, again, made weakly to be a sacrificial part that basically would break and give up its life and save the gears in the gearbox. So the first thing I got to do before I even think about trying to solder this is clean this up really well. So I'm not going to get all hog crazy with the parts washer on these little tiny parts. This is the stuff I was using on the Hendy that was off-gassing really badly. It's the 3M foam engine degreaser, but I'm not going to use that much of it, so I'm willing to live with the smell for some little amount that I'm going to do here. This really comes out with a lot of force because it's designed to also kind of blast the grease off the motors. So I'll let that sit for a couple minutes. Yeah, it's been a couple of minutes. Give it a little bit of a scrub. Old toothbrush here. And this just rinses off with water. Alright, that takes care of the grease. But you can see there's paint all over this, so I need to remove the paint in the area where I want to try and flow all that solder. Now we'll switch to dry that off and then switch to some mechanical means of removal. Here's what a couple minutes on my soft brass wire wheel did for me. But I want to get this area up in here, and I can't get in there with that wire wheel. So I'm just gonna have to hand scrape that area. And it wouldn't hurt to rough up the surface a little more anyways. Right now it's actually pretty smooth. And if I rough up that surface, it'll help with the, hopefully it'll help these solders stick. Of course, I'll be using a flux. And I believe acid core flux is going to be the best bet for this material. I just grabbed a couple of little different implements of destruction here and making short work of the little bit of paint residue that was left on there in the area that I want to work with. Can't even get right down. I got a little scratch all. Get right down into the corner if I want to. And I'm just kind of scratching this up, giving it a little bit of a rougher surface for that solder to want to flow and stick to. It's all theoretical. Of course, this is going to be the most difficult part. Building up over here enough so I can get some strength out of this repair and yet still stay clear of these holes far enough to allow me to get the screws in. Can't go on the back here anywhere. Can't do anything here because that's going to go up against the bed. So I got to preserve that area there. Looks like I can definitely try and get some on there though, so clean that little bit of paint off right there and give me a little more. Solder is going to be so soft. That one positive aspect of that being so soft is that if I do need to file off any that flows over past where I want it to be, I can just use some small files and do a pretty precise job of filing it off, getting it out of where I don't want it. Alright. Is what it is. Thinking I want to use this small vise right here to hold the pieces together. It's almost looking to me like if I put this in at the right angle and I have pressure right on here, it might be able to actually hold that together right where it's broken pretty cleanly. So we'll try that. I might have to, I've actually got a groove in one of the jaws right here that might even work perfectly, yeah, see, to hold that like that, and then I might just have to build up something on this side to get it at the right height. So yeah, that's not too bad. It's holding it just at the right angle and put together just the way I want it. So what the hell? Let's give this a shot. I'm gonna grab me some flux paste and flux this puppy up. I do have some lead-free solder for plumbing, which is a silver-based solder. I'm going with the silver solder. Just bending it, I could definitely feel that this solder has more strength than the tin lead. So this is going to be the better choice, I think, between the two. And then I've got a couple different fluxes. I've got a water-soluble flux that doesn't even say what the ingredients are. I've got a lead-free solder flux, which says that it uses aluminum oxide and one of the other oxides. I forgot which one. But I want to use this flux that I have because this flux has tin antimony along with hydrogen oxide, aluminum oxide, and chlorine oxide, chloride, I don't know, I forget what the heck all the chemicals were, but this is the most caustic. I want a more acidic uh, so, flux. And then ideally, I'd be using my MAP gas torch, but I forgot that I ran out of MAP gas, and I had been resorting to using these big propane bottles. So hopefully I'm going to be able to generate enough heat. I mean, I know I could solder copper pipe with propane, but I really would like to try and get this up to temperature more quickly. But it is what it is. Okay, I've applied my paste flux. Let's see if I can't zoom in a little more. Let's do some solder. Not sticking at all. Not sticking one bit. Very interesting. Yeah, stuck right to that screwdriver, no problem. Well, that ain't happening. What a bummer. I got that pretty hot. That looks horrible. Very unimpressive. I'll let that cool, but it's not doing anything. It's funny, I had a brief glimmer of hope there when I actually had this sticking to this, but then it only took one little bang and it broke right off. I mean, barely touched it, it broke right off. Question is it because I only had this much of the solder actually sticking to here? I mean, how well is this solder right here adhered to this? Ah, damn good. It is sticking. I'm gonna give this one more shot with a different type of flux. I didn't like the way that flux was acting on this alloy. Let's see if this flux gives us a little more adhesion.